Welcome to Everyday Mathematics. We're very excited to share with you our new math video on problem 3 of 2024 MIT Integration B Finals. Whether you're a lifelong learner or a student, we believe you will get a few nuggets from this video. We've seen other solutions to this problem and believe they may be a little counterintuitive or derived. And here we will provide a more straightforward and succinct solution to the problem. We'll be slow and methodical, so if you have your cup of tea or coffee brewing, please pause the video and go and get it. As we proceed, if you've not subscribed to our channel, we would really love if you subscribe to our channel, and we promise to keep making more fun videos for you. The problem we're looking at is the definite integral from x tending to negative infinity to x tending to positive infinity of 1 over x to the power 4 plus x cubed plus x squared plus x plus 1. So we're going forward to solve this problem. So solving this problem, first we're going to factorize the denominator of the integrand. So looking at x to the power 4, x cubed plus x squared plus x plus 1, the first thing I would like to do is, so if you have x squared plus a half x plus 1 squared, this is the same as x to the power 4 plus x cubed plus 1 plus 5 over 4 x squared plus x plus 1. And so x to the power 4 plus x cubed plus x squared plus x plus 1 is the same as x squared plus a half x plus 1 squared minus 5 over 4 x squared, right? So that's one thing we can do. Then using the difference of 2 squared, x squared minus b squared being equal to a minus b bracket a plus times a plus b. So we can form this into this perfect square so that it looks like b. So this is the same as root of 5. So root of 5 over 2 squared, right? So we can go ahead and do that. So instead of, we just did that. Okay. And so now a minus b is going to be x squared plus a half x plus 1 minus root 5 over 2x. A plus b is x squared plus a half x plus 1 plus root 5 over 2x. Now I would like to collect the like terms together. So for example, the negative root 5 over 2x and then combine it to half x. So that becomes x squared plus 1 minus root 5 over 2x plus 1 times x squared plus 1 plus root 5 all over 2x plus 1. So now we've gotten to this very good step that we wanted ourselves to be. So we'll continue. So our integration now becomes, so the integration of 1 over x squared, x to the power 4 plus x squared cubed plus x squared plus 1 plus x plus 1 is the same as the integral from x tending to negative infinity to x equals to tending to positive infinity, or 1 over the product of x squared plus 1 minus root 5 over 2x plus 1 and x squared plus 1 plus root 5 over 2x plus 1. Now we can express this fraction that we have here into partial fraction, or partial fractions as follows. Now, when expressing partial fractions, obviously we have a known constants that we're going to create, a, b, c, and d, such that the numerator is a polynomial 1 degree, and we assume it's a polynomial 1 degree less than the denominator. So we have to assume, and then we'll go ahead and derive what A, B, C, and D are. So when we multiply the left and the right hand side with the product of x squared plus 1 minus root 5 over 2x plus 1 and x squared plus 1 plus root 5 over 2x plus 1, and so we get on the right hand side 1, on the left hand side 1, on the right hand side we get ax plus b times x squared plus 1 plus root 5 over 2x plus 1 plus cx plus d times x squared plus 1 minus root 5 over 2x plus 1. And then we continue expanding the product on the right hand side and collecting like terms together. We get a plus c x times x cubed plus 1 plus root 5 over 2a plus 1 minus root 5 over 2c plus b plus d, all times x squared, plus open brackets 1 plus root 5 over 2b plus 1 minus root 5 over 2d plus a plus c, all times x plus b plus d. So we got the expression 1 is equivalent to a plus c x cubed plus open bracket 1 plus root 5 over 2a plus 1 minus root 5 over 2c plus b plus d, or close bracket times x squared plus 1 plus root 5 over 2b plus 1 minus root 5 over 2d plus a plus c, close bracket times x plus b plus d as the constant. So as we can see, we have no x cubed term on the left hand side. So what that means is that a plus c equals to 0. Equally, since we have no x to the power 2 term in the left hand side, on the left hand side, that means that this part here is also 0, 1 plus root 5 over 2a plus 1 minus root 5 over 2c plus b plus d equals to 0. And also, since we have no x term on the left hand side, that means that this term also equals to 0. So 1 plus root 5 over 2b plus 1 minus root 5 over 2d plus a plus c equals to 0. And then the only thing that's on the left hand side is 1. So this constant here is equals to 1. So b plus d equals to 1. Okay. And meaning that from the top here, it means that our c is equals to negative a. And then we can proceed since b plus d equals to 1, first of all, let's collect like terms here. So we have a plus c over 2, and then we have a minus c over 2 plus b plus d. And then here we have b plus d over 2, collecting like terms, and then root 5 times b minus d over 2 plus a plus c. And then from here, we can see that d is the same as 1 minus b. So that's the first thing we can do. Now, seeing that b plus d equals to 1 here, and then a plus c is 0, so this goes to 0 here. Let me get this. So this is 0, and this is 1. And then since a minus c, c is equals to negative a, we get 2a here. And that results into 2 times this root 5 over 2a plus 1 equals to 0. Same thing here, since this is 1 coming from here, and then a plus c is 0, this is 0. And then since b minus d, since d is 1 minus b, so b minus, in bracket 1 minus b is the same as 2b minus 1. And so we have a half from here, 1 over 2 times plus root 5, open bracket, 2b minus 1 over 2. And since this is 0, so that is equals to 0. And so from here, we can clearly see that the 2's here cancel. And so root 5a equals to negative 1. And then we can now take this a half onto the other side. Or we just multiply across by 2. So we have 1 plus root 5 in bracket 2b minus 1 equals to 0. Since we found that a root 5 times a is equals to negative 1, that means that a is therefore negative 1 over root 5. And also since c is equals to negative a, that means c is 1 over root 5 positive. Also, equally, since we saw that 1 plus root 5 times 2b minus 1 equals to 0, now we can take 1 to the, we can subtract 1 on both sides, so we have 2b minus 1 root 1. Then if we divide by root 5, we have 2b minus 1 equals negative 1 over root 5. And therefore 2b is the same as 1 minus 1 over root 5. And therefore b is the same as 1 minus 1 over root 5 over 2. Also, since d equals to 1 minus b, as we saw previously, that means that d is the same as 1 minus 1 over root 5 over 2. Make a common denominator for both, so we have 2 here, which makes this 2. 2 minus 1 is 1, and then minus minus we have plus 1 over root 5. So d is the same as 1 plus 1 over root 5 over 2. The partial fractions that we're seeking to create is now attainable since we know a, b, c, and d. A is negative 1 over root 5. B is the same as 1 minus 1 over root 5 over 2. C is the same as positive 1 over root 5. And D is the same as 1 plus 1 over root 5 over 2. So this is our partial fractions. The first is negative 1 over root 5 x plus 1 minus 1 over root 5 over 2 all over open bracket x squared plus 1 minus root 5 over 2x plus 1 plus 1 over root 5x plus 1 plus 1 over root 5 over 2 all over x squared plus 1 plus root 5 over 2x plus 1. So this is our partial fraction. And this now is going to make things easier for us to now integrate this problem. Now, since we have this partial fraction that we're looking for, now we can go ahead and solve this problem. Which means that our integral now becomes the integral of 1 over x to the power 4 plus x cubed plus x squared plus x plus 1 from x tending negative infinity to x tending to positive infinity now is same as the integral from x tending to negative infinity to x tending to positive infinity of negative 1 over root 5x plus 1 minus 1 over root 5 over 2 all over x squared plus 1 minus root 5 over 2x plus 1 plus 1 over root 5x plus 1 plus 1 over root 5 over 2 all over x squared plus 1 plus root 5 over 2x plus 1. So we can separate this into two separate integrals. The blue integral that deals with this first portion here, right? And then the green integral that deals with this second integral. So we're going to deal with these two integrals separately and then combine the results we get. So this is the new integration set we have. We have the blue and the green integrals. And then, so we're going to start and focus on the blue integral. Yeah. And let's focus on the denominator. If you have the polynomial, so let's look at this polynomial here. If you have the polynomial x squared plus bx plus c, this is the same as x, because we're trying to create a perfect square involving that denominator. This is the same as x plus b over 2 squared minus b squared over 2 squared, which is 4 plus c. So that's what we're going to try and do, because this is our b here. And so we're going to have 1 minus root 5 over 2, which is 1 minus root 5 over 4 plus x squared. That's what we're going to do here. Because let's deal with the blue integral first here. As we can see, what we've done is we have focused on the denominator, keeping the numerator as it is, and so we have x plus 1 minus root 5 over 4 squared minus 1 minus root 5 over 4 squared, then plus 1, right? So now 1 minus 5 over 4, 1 minus root 5 over 4 squared is the same as 1 minus root 2 root 5 plus 5 over 16. But then this is negative, so we have to subtract 1 minus this. I'm going to do that. So this eventually becomes 16 as our denominator, and then making this become 16 minus 1, 5 plus 1 is 6, so minus 6, minus minus, so we have this becomes 2 plus 2 root 5, right? And this now becomes 10 plus this becomes 10 plus 2 root 5 over 16 divided by 2, 5 divided by 2, because and this divided by 2 is 8. So we have 5 plus root 5 over 8, replacing this term here. So that's what we have here. Now this is x plus 1 minus root 5 over 4 squared plus 5 plus root 5 over 8. And that is progress. That is progress. We have our integral here. The integral from x tending negative infinity to x tending towards infinity of negative 1 over root 5 x plus 1 minus 1 over root 5 all over 2, all that over x plus 1 minus root 5 over 4 close bracket squared plus 5 plus root 5 over 8. So usually with such substitution, if you have something like, for example, 1, if you have 1 plus ax squared plus b, the trick is to say let x be equal to or let ax let's assume this is also squared. So we'll say let x equal to root root of b tan theta, such that when you substitute in and you say let this also be squared, we have in place of ax we'll have b tan square theta plus b, right? So that you can pull b out the denominator and you have tan square theta plus 1, right? And so this becomes sec square theta, and since we have a dx there, then you're able to cancel that out. So we're going to now use this. We say x plus 1 minus root 5, this entire thing, be equal to the square root of b, which is 5 square root of 5 plus root 5 over 8 tangent theta, such that dx d theta is the same as still this constant 5 plus square root of 5 plus root 5 over 8 sec squared theta. And so dx now is the same as our, we can substitute for dx with root of 5 plus root 5 over 8 sec squared theta d theta. So this is our the variable what can be substituted for dx. Then looking at the limits here, as x tends to negative infinity, then from here, x tends negative infinity, tan theta also tends negative infinity, and what that means is that the arctangent of that theta tends to negative pi over 2. When x tends to positive infinity, tan theta also tends to positive infinity, and so theta, the arctangent of that, tends to pi over 2. So these are the new limits with the new substitution that we're going to involve here. The integral in x domain now can be transformed into the theta domain. So in place of x, we can substitute the square root of 5, the square root of 5 plus root 5 over 8 tan theta minus 1 minus root 5 over 4. And in place of x plus 1 minus root 5 over 4, we can substitute with square root of 5 plus root 5 over 8. Now that squared, we have 5 plus root 5 over 8 tan squared theta, and then this constant here remains, right? And the constant here also remains. And then in place of dx, we have the square root of 5 plus root 5 over 8 sec squared theta. So we can go ahead and pull this constant out, right? We pull it out, and we have tan squared theta plus 1. And then we can pull this constant and this constant out. So we have square root of 5 plus root 5 over 8 over 5 plus root 5 over 8 out here. And then as you can see here, we have negative 1 over root 5, square root of 5 plus root 5 over 8 tan theta minus 1 minus root 5 over 4 close bracket plus 1 minus 1 over root 5 over 2. Now tan square theta plus 1 is the same as sec square theta, and we're going to see that this and that can cancel, but we'll see that in the next step. This is the integral we got in our last step, but we're quickly going to see that the sec squared theta term in the denominator, as we said previously, is going to cancel out with that, and then this division here, we're left with 1 over root 5, square root of 5 plus square root of 5 over 8 times the integral from theta equals to pi over 2 to theta equals to pi over 2, negative pi over 2 to positive pi over 2 of negative 1 over root 5 times this root square root of 5 plus root 5 over 8 tangent theta plus we multiply negative 1 over root 5 times this, so we get plus 1 minus root 5 over 4 plus 4 times root 5 plus 1 minus 1 over root 5 over 2. And we can do some quick math here. So 1 plus root 5 over 4 root 5 times 1, can multiply root 5 here times root 5 in the numerator, such that we have root 5 minus 5 times 5 is 5, and then this is 4 times 5, which is root 5 minus 5 over 20, right? And then this here is the same as root 5 minus 1 over 2 root 5. And then multiplying root 5 in the denominator and in the numerator, we get 5 minus root 5 over 2 times 5, which is 5 minus root 5 over 10. So adding them together, we get 5 times root 5 over 10 plus 5 root 5, sorry, minus 5 over 20. And so common denominator 20 divided by 10, we have 10 minus 2 root 5 plus 5 minus 5. So we get 5 minus 5 here is 5 minus root 5 over 20, right? And so substitute here in place of this convoluted stuff here that we have here. So 5 minus root 5 over 20. So this is what we have here. Okay, we'll continue. We do have our integral. We have now 1 over square root of 5 plus root 5 over 8 times the integral from theta equals to negative pi over 2 to pi over 2 positive of negative 1 over root 5 times the square root of 5 plus root 5 over 8 tangent theta plus root 5 minus root 5 over 20. So tan theta let's just try to see. Tan theta is the same as sine theta over cos theta, which is the same as negative d derivative of cosine theta, sorry, of all over cos theta, such that the integral of tan theta is equals to negative natural log of cosine theta. Okay, so this is easily integratable. But we'll also look that if you're plotting tan theta from theta equals to negative pi over 2 to pi over 2, the curve is something like that, right? Symptotic about pi over 2, negative pi over 2. So this area here is under the curve, under the x-axis, the theta axis, and this area here, they're equal but opposite in sign. So the integral here is just 0, but we could also go ahead and show why that is 0 just with the limits. So once we have natural log cosine theta here at pi over 2 cosine theta is 0 and negative pi over 2 cosine theta is 0. So this is the same as limit as x tends to 0 of log x minus log x, right? Which is the same as limit as x tends to 0 of log x over x, which is equals limit as x tends to 0 of log of 1. So in other way, putting in these limits, this part here tends to 0. And then since we have theta here, this becomes this constant 1 over square root of 5 plus root 5 over 8 times 5 minus square root of 5 over 20 in bracket positive pi over 2 minus pi over 2, which becomes pi, as we see here. So that's where things have brought us. And so we do have our answer here, but let's try to express it such that we don't have this many integrals, just consolidating things. First of all, this 8 here can go up here, and we know that square root of 8 is the same as 2 square root of 2 times 4. Square root of 4 is 2, so this is the same as 2 root 2, right? And then so our expression here, we can simplify this further so that we have 2 root 2 over square root of 5 plus root 5, and then we have 5 minus root 5 over 20. Okay, so we can multiply the numerator and denominator with the same thing, and we choose to multiply with the square root of 5 plus root 5, right? But even before that, these 2 and the 20 divide, so we have 10. And then obviously multiplying both the numerator and the denominator by the same thing, we just want to remove the square root sign in the denominator. So we came up to here where we multiplied with the same thing, but now we are left with root 2 here. And since this multiplication here now results in now just 5 plus root 5 over in the denominator here. And then now we can also multiply with the conjugate, just trying to remove the instead of plus here we have a negative here, so we're trying to remove the square root in the denominator. So this means that we have 5 root 5 minus root 5 squared, and that's the same as 30 minus 10 root 5. And then after this conjugate multiplication, we get 20. We see that this goes away, and then we multiply root 2 across, so 2 now goes into the root sign, so we have 10, and then we have 2 root 5 there. And here we have 3 minus root 5 times square root of 10 plus 2 root 5 over 20 pi. So this is what we get from the blue integral. Now we're going to go and try and look at the green integral, use the same steps to get the answer. Since our integral now involves blue and green, now we're going to focus on the green integral, and we'll use the same steps that we use in solving the blue integral. First, we want to create a perfect square involving the x term, and so how we do that is just the same way where we do x plus 1 plus root 5 over 4 squared, and then we subtract this square of this term here. And that can simplify into now the 1 minus the square of 1 plus root 5 over 4 simplifies into 5 minus root 5 over 8. Obviously getting our integral, the same very steps we use with the blue integral, we're just going to go ahead and now do the substitution, right? So we say let this part here, x plus 1 plus root 5 over 4 be equal to the square root of 5 minus root 5, square root of root 5 minus root 5 over 8 tan theta. And so dx d theta is the same as square root of 5 minus root 5 over 8 sec squared theta. So we can substitute dx with square root of 5 minus root 5 over 8 sec squared theta d theta. And then the limit, the same thing as x tends to infinity, theta tends to negative pi over 2. As x tends to positive infinity, theta tends to pi over 2. So going forward, we can now transform our equation from the x domain to the theta domain in a very similar manner we did previously. In place of x, we have square root of 5 minus root 5 over 8 tan theta minus 1 plus root 5 over 4. And so everything kind of takes shape here. We're able to pull 5 minus root 5 over 8 out, and so we're left with tan squared theta plus 1, and this is the same as sec squared theta. So we can also pull now this and this out. So we have square root of 5 minus root 5 over 8 over 5 minus root 5 over 8. And then denominator we have sec squared theta, and on this end also we have sec squared theta. So this and that can cancel. Going forward, the process continues. As we said, this and that cancel. Now this divided by this, we have 1 over square root of 5 minus root 5 over 8 times the integral from theta equals to pi over 2 to pi over 2 of 1 over root 5. This time is positive, times square root of 5 minus root 5 over 8 tan theta minus obviously 1 over root 5 times 1 plus 5 over root 5 over 4 becomes now negative, the sign here, persisting 1 plus root 5 over 4 root 5 plus 1 plus 1 over root 5 over 2. Now this part here, we can simplify it further. That's the focus that we're going to work on, and so it becomes 5 plus root 5 over 20. Looking at the previous integral, we now know how tan theta evolves. Tan theta can be integrated to the natural log of cosine theta, and we already know that with the limits of negative pi over 2 and pi over 2, this here tends to 0. And so we are left with 5 plus root 5 over 20 theta, which when you include the limits, right? So pi over 2 minus pi over 2, this becomes pi, and then this constant. So we have 1 over square root of 5 minus root 5 over 8 times 5 plus square root of 5 over 20, and then this pi just comes here. So this constant comes from here. This comes from here right away. Okay, and do some further simplifications, since we already have 1 over square root of 5 minus square root of 5 over 8 times 5 plus root 5 over 20 pi. This 8 here can go up, square root of 20 can go up, and we have, since we know square root of 8 is the same as 2 root 2, and then we have 2 root 2 over 5 square root of 5 minus 5 square root of 5. And the next thing we would want to do is we multiply both the numerator and denominator by square root of 5 plus root 5. And what that means is that even after cancelling with this, so that we have 10 here, we have square root of 2, 5 plus root 5, 10, and under the square root sign we have square root of 20, because we found out that 5 plus root 5 times 5 minus root 5 is the same as 20. So we still have the square root sign there, and 20, square root of 20 is the same as square root of 4 times 5, and then square root of 2 is 2, so we have 2 root 5, right? And then we'll keep proceeding here. And so in place of square root of 20, we have 2 root 5. And so this 2 times 10 here becomes 20. And then we can multiply both the numerator and denominator by square root of 5. And then the square root of 2 multiplied across, this becomes 10, and this becomes 2 root 5. And so when you multiply 5, root 5, numerator and denominator, the denominator becomes 5, and then the numerator becomes here 5 root 5 plus 5 times square root of 10 plus 2 root 5. And so this 5 goes, and this becomes 1. So we have square root of 5 plus 1 over 20 times the square root of 20 plus 2 root 5 times pi, obviously. That is what is due to the green integral. So going further and combining the two integral, we already knew that the answer to the blue integral is 3 minus root 5 times square root of 10 plus 2 root 5 over 20 pi. And so the green is root 5 plus 1 over 20 times square root of 20. So we forgot pi here. This and that cancel, so we get 3 plus 1, which is 4 over 20 times square root of 10 plus 2 root 5. And so 5 divided by 4 here goes 1, divided by 4 here goes 5. And so the answer is now square root of 10 plus 2 root 5 over 5 times pi. And this is the final answer. So it's been pretty winded, but we've come to the answer that was provided in the question. An absolute pleasure solving this interesting problem. If you do have any question, please, we welcome any form of questions you may have. If you have suggestions, other ways to go about solving this problem, we do welcome your suggestions. So until next time, bye-bye.